Welcome to section 9.5. We're dealing with the binomial theorem. This is actually my favorite section of the entire chapter, and it really is a nice turnaround from the math induction proofs that we did in 9.4. So let's take a look. We are going to talk about expanding binomials. Now, we did this in Algebra 2. This is a complete review section in Algebra 2. And so if you kind of remember how to expand binomials, then it's not a big deal. If you don't remember, it's going to take us a little bit of time. So here we go. Let's start off with the basics. We want to write these exponentials in kind of in just general terms. What do they look like? Okay, so if I talked anything to the 0 power is just 1. And I'm going to put it in the middle for a reason. I'm going to go with me. Take a look at, if I take x plus y squared, I just get an x and then plus a y, right? If I square this, it's like saying x plus y times x plus y. I FOIL it. You get x squared plus 2xy plus y squared. If I cube it, then I'm doing 3 FOILs, and what I end up getting is x cubed plus 3x squared y plus 3xy squared plus y cubed. All right, I hope you're starting to see something, but what we want to be able to end up doing is figuring out what x plus y to any power would be. Now, we want to look at just coefficients. When we did it to the 0 power, all we got was a 1. When we did it to the first power, our coefficients were a 1 and a 1. When we did it to the second power, our coefficients of x squared were 1, and then 2, and then 1. And our third power was 1, 3, 3, 1. And my guess is you're starting to remember a bit about binomial. Okay? But we had this triangle that we talked about last year, and where we had this, where the 0 row was 1. The first row had coefficients 1 and 1. The second row had coefficients 1, 2, and 1. The third row had coefficients 1. Let's actually try this, shall we? 1, 3, 3, 1. And my guess is you can get me the fourth row. Well, let's talk about how to get it. To get the 2 here, we add the 1 and the 1 to get 2. To add the 3, to get the 3, we added 1 and 2. So to get this, we always start with a 1 and end with a 1. To get the numbers in the middle, we add up the numbers above it. So this is a 4. 3 plus 3 makes a 6. 3 plus 1 makes a 4. And we know that this is called Pascal's triangle. All right, we can use this triangle, and the triangle actually came about by using combinations. Okay, and I want to go back through and talk just briefly about combinations, just so that you can kind of see. But I think most of us, for the most part, can write down Pascal's triangle. But I want to talk about combinations so we can use a shortcut when we have to go to like the 8th row or the 10th row. Okay, so let me slide this down. Okay, so if we look at the 0 row, we know that we can start with combinations. And a combination of r things, of n things taken r at a time. Your book writes it like this, and this is the higher mathematical writing. What it just means is n things taken r at a time, and the formula from Algebra 2 was n factorial over n minus r factorial with an extra r factorial. And in Algebra 2, we really kind of went with what's the difference between combinations and permutations, and we're getting to that. But at this point, I need you to know notation. This is brand new, but as you get higher and higher in mathematics, the more they go that way. So let's talk in terms of combinations. We always start with the 0 row, so we do 0 combinations, and we always start with 0. This will give us 1 if you plug it in your calculator. For the first row, we start with 1 combinations of 0, and then we do 1 combination of 1. Both of those will answer of a 1. Second row, we start with 2 combinations of 0, then we do 2 combinations of 1, 2 combinations of 2. So you start at 0 and you work your way up to the row. 1, 2, 1. I'm guessing you can kind of see this is 3 combinations of 0, 3 combinations of 1, 3 combinations of 2, 3 combinations of 3, 4 combinations of 0, 4 combinations of 1, 4 combinations of 2, 4 combinations of 3, and 4 combinations of 4. And you can kind of see that. So as I look at this, we're going to ask you questions like this. What is the coefficient for the third value in the 8th row? Most of you will assume it's 8C3. But the answer is no, because every row starts with 0. So if you're talking about the third value, we're actually doing the second combination, because you start 8C0, 8C1, 8C2, so it's 28. Now you can stick this in your calculator. Remember, your combinations is in your math menu, and you go over to probability, and I believe it's like number, 3, something like that, okay? But this is the idea, okay? Now, binomial formula, I could write this out for you, but truthfully, I think this is harder to do in this form. And so what I'm going to do is actually walk you through an example of binomial expansion, and then kind of talk about that as we go through. Okay, so here we go. As I look at this first one, we're gonna start off really easy. Okay, how do you find what the expansion looks like when you take x plus y to the 5th? Now let's talk about a shortcut. This 5 says go to the 5th row of Pascal's triangle. The problem is, if you don't know Pascal's triangle well enough, you're going to might have to draw it out to find the 5th row. There is a shortcut. If you go in your y equals menu and take 5 NCR of x, then what you can do is go to your table and you'll find the combinations in order for the 5th row. And so if we do that, you get 1, I'm going to leave a space, 5, leave a space, 10, leave a space, 10, leave a space, 5, leave a space, 1, leave a space. Now, other teachers might show you this in a different way. I'm going to try and go the easiest way I know how, and I'm always going to start with my combinations, okay? The second thing that I'm going to do is I'm going to start with my x's, and your first term starts with the exponent they give you. So x to the 5th, and then it works its ways down. X to the 4th, x cubed, x squared, x to the 1st, x to the 0. Now I'm going to write out every term, and then I'm going to use my algebra skills to get rid of what's not needed. If I start the x's at the 5, then I start the y's at the 0. So y to the 0 and work my way up. Y squared, or y to the 1st. Let's try adding, right? Y squared, y cubed, y to the 4th, y to the 5th, and between each of these is an addition sign. Now, once I do this, and this one tends to be really easy because there's less simplification, anything to the 0 power just goes away, because anything to the 0 power is 1. So all I'm going to do now is rewrite this so I like the look of it. What I have is x to the 5th plus 5x to the 4th y plus 10x cubed y squared plus 10x squared y cubed plus 5x y to the 4th plus y to the 5th. And this is what it would look like if you decided to FOIL out x plus y 5 different times. What's great about the shortcut for binomial expansion using combinations is that there's no need to screw up multiplication. You don't have to combine like terms. It's done for you. Okay, so let's try one more. 2n minus 3 to the 4th. Again, I start with my exponent. This is the 4th row. I hope you already know the 4th row, but if not, use the combinations like we did above. But 1, 4, 6, 4, 1 are our combinations. Now this is 4 combinations of 0, 4 combinations of 1, 4 combinations of 2, 4 combinations of 3, 4 combinations of 4, just so that you're aware, you know your combinations. Okay, then I start with my first term, and I raise it to the power that I'm given. Now, because there's more than one thing, I'm going to put this in parentheses. So 2n to the 4th, 2n cubed, 2n squared, 2n to the 1st, 2n to the 0, and like I said to you, I'm always going to write out a term. I'll cancel it out later if I need. Now, I'm going to start second with the -3, and because there's a negative there, I'm going to put that in parentheses as well, and I start that to the 0. -3 to the 1st, -3 to the 2nd, -3 to the 3rd, -3 to the 4th. Now, you'll notice, and I'm hoping you'll kind of see, that before I do any distributions or anything like that, all of my exponents together add to 4. 3 plus 1 makes 4, 2 plus 2 makes 4, 1 plus 3. Now that only happens before you do the algebra. Okay, once I do the algebra that may change, but at this point in time all of your exponents should add up to 4. Now I'm going to cancel out the 0 powers because those don't matter. I'm going to change my color so I can kind of show you what I'm doing as I distribute. But exponent rule says the 4 goes to both. So 2 to the 4th is 16, n to the 4th. And I'm going to take this actually in an extra step just because I'm feeling like I'm going to screw something up if I don't. 2 cubed is 8, so I have times 8 with an n cubed times -3 to the 1st is -3, plus, that should be just to the 1st, I have a 6 times 2 squared is 4 and an n squared times, when I do -3 squared, I get +9. I have 4 times 2n times -3 cubed is a -27. And -3 to the 4th is a +81. Okay, so now I'm going to simplify as I go through. My first term is 16n to the 4th. And actually, I'm going to not put a plus sign because there's a negative there. You could say plus a negative, but 4 times 8 times -3. So 4 times 8 times -3 is a -96 with an n cubed. I'm going to do it again. 6 times 4 times 9 is a +216 with an n squared. I'm going to do it again. Oh, that was close. 4 times 2 times -27 is a -216 with an n, and then I've got a +81. I'd suggest when you have to do some distributions that you write an extra line of work. Some of you may not need it, and that's perfectly fine. Okay? Now, I'm going to give this one on your own. And you have to do it in order for do for notes points. You know what, I think I used the wrong do, so let's actually use some correct English here. Do for your notes points, okay? This one is a little tougher. You will have to use your exponent rules, but that's why I love this. All right, let's show you another idea. Just a couple of them, and then we'll be done for 9-5. The homework at the bottom, again, please look at my homework schedule because these might be different, but just kind of be aware of that. Okay, find the 6th term of a plus 2b to the 8th. Okay, well this here says the 8th row, right? If I'm doing the 6th term of the 8th row, I'm actually doing the 5th combination. Because don't forget, I start with 0. So because of that, I'm doing the 5th combination. Now, whenever you do your combination, that affects the second quantity. So when I do my 2b, this is to the 5th power, and we said when I do my a, these two exponents should add up to 8. So if this is 5, then this one has to be 3 because 3 plus 5 equals the 8th row. So I'm going to actually put this all in. 8 combinations of 5 is 56. Then I have an a cubed. Then I have a 2 to the 5th power. And 2 to the 5th power is 32. And I have a b to the 5th. Now I'm going to multiply 32 and 56. I get 1792, a cubed, b to the 5th. And there is my 5th term. And here's the idea to keep in mind. The combination always affects the 2nd term. And I want you to keep in mind. And look above. I mean, look, if you're like, Mr. Panic, I so don't believe you. Okay, fine. But look at the questions above and write them down in terms of combinations, and you'll see that the combinations then will match the 2nd exponent. Okay? So that's one way that we'll write it, is find a specific term. Don't forget, if we give you a term, it's always actually one lasting combination because you have to count the 0. The second question just wants the coefficient. So they're telling you that I should get a to the 6th and b to the 5th. All I want is the numbers that are in front. Okay, now I'm dealing with the 11th row. And so let me talk about how this works. Here's what I'm going to do. I'm going to start with 3a and a negative 2b. Now I want my a to be a power of 6. So this one has to be the 6. I want b to be a power of 5. So the b has to have an exponent of 5. But the question comes down to what combination am I using? Because the combination affects the 2nd term, then I'm going to take the 5 and it's going to be 11 combinations of 5. Okay, so let's write this out. 11 combinations of 5 is 462. Okay, now I'm going to take 3 to the 6th and get 729. Do I really care about the a and the b? No, because I only want the coefficient. So I'm going to scrap the a because they already told me a should go to the 6th. The next one, I'm going to take negative 2 to the 5th power, which is negative 32. So I'm going to multiply 462 times 729 times negative 32. And the coefficient I get is negative 10,777,536. And again, I don't care about the a and the b because they're already telling me what a and b looks like. Because I want the coefficient, the only thing I care about then is the numbers. And again, don't forget, the combination matches your 2nd exponent. And that's kind of the key as you're finding specific terms. So that's the end of 9.5. Thanks for watching. I hope you enjoy binomial expansion as much as I do.